in your do now, you selected one of these three choices and you explained why you selected that choice using because and so. Today we're going to work on an economic idea, but before we start talking about the economic idea, we're going to work on a simulation. So the simulation deals with a zombie outbreak, and this will show us the scale of cause and effect. So with this zombie outbreak, we have strain A. Strain A, on each day of the outbreak, the original zombie, or patient 0, can infect 3 people. New zombies cannot cause infection. So the infection can only come from patient 0. So let's take a look at what that looks like on the chart. So here on the chart, you see on day 1, we have 3 zombies, the original zombie plus the 2 people he infected. On day 2, that number grows to 7. Now remember, only the original zombie can cause infection. On day 3, the original zombie goes out and infects 3 more people. On day 4, the same thing. On day 5, the number has grown to 16. Now, in order to stop or contain the spread of this zombie infection, you would simply contain or stop patient 0, okay? So this is going to show us linear growth, and I'm sure you've heard that in math. In economics, we call this simple growth, okay? Now, as we all know, viruses can mutate, and you learn that in living environment. So for strain B, each day of the zombie apocalypse with this strain, each day one person can infect another person. So now new zombies and old zombies can and will infect people. So let's see what that would look like on the chart. So here's the chart for that growth. So on day 1, you have 2 zombies. On day 2, you have 4 zombies. Those 2 went out and infected 2 more people. On day 3, those 4 have gone out and infected an additional 4 people. On day 4, that number has grown to 16. And on day 5, that number has grown to 32. You can see how that is a steeper growth, right? It started off slower than linear growth, but now it's become a steeper growth. That is called exponential growth, and I know you've heard that from math. In economics, we call that compounding growth. So let's compare the 2 graphs together. Here we have graph A, which is simple growth or linear growth, right? It's steady growth and seems to be almost in a straight line, okay? Strand B, we have what we call compounding growth, okay? So again, with strand A of the virus, only the original zombie could infect other people. Now, that outbreak seems to be worse at first, but when we compare that to strand B, the growth is much steeper as time goes on. So compounding growth takes a little bit longer to get going, but as you can see, it does become worse, okay? Now, when we compare this to economics, we can see that line A is like if you took your money and you just put it in a drawer or put it under your mattress, you are only adding to your money. It's not making you money. Okay, so every time you go to work or every time you go to the store and you save your change, you're the one adding to the savings that you have, and it's not making you money. So this is just addition. You're just adding to the amount of money you have under your mattress. When you see compounding growth, okay, compounding growth is like when you put your money in a bank account or you invest it in an account that earns interest. This is when your money will make you money. Okay, so I know it starts off slow, but as you can see over time, and this is the only thing that confuses people when it comes to interest, it does take some time, but over that amount of time, you grow much more than if you had just simply put the money under your mattress. So let's see that in images, okay? So here, let's say you had $10,000. You take that $10,000 and you put it in the bank, and in the bank account, you're going to get 5% simple interest over 3 years. Which means that you are going to get 5% interest or $500 interest on that $10,000 every 3 years, which means you'd walk away with interest equaling only $1,500, right? Which would mean that your original $10,000 made you $1,500. Seems like a good deal, right? But let's see how compounding interest works, okay? You take the same $10,000 investment and you put it in a bank account. In that account, you're now getting 5% compounded annually, which means that your money is going to make money on your money. I know that sounds confusing, but let's see how it looks, okay? So in year one, you make the same $500 that you made in the simple interest, okay? But here's where it gets different. In year two, that $10,000 investment is not what you're going to get interest on. You're going to get interest on that $10,000 plus the $500. So now you're getting interest, 5% interest in the second year on $10,500, right? Which means that in year three, you're not getting interest on the original $10,000. You're getting interest now on $10,500, which comes out to $11,025. So over time, you can see that your money actually made you money. You didn't have the original $500, right? But the original $500 keeps getting added to by the 5% interest annually. So you actually walk away with more money than you had, and even more money than you had with a simple interest, okay? So what you're going to do now is you're going to work on a reading. You're going to work on the 2 in-text annotations and the paragraph. Be sure to check the rubric at the bottom to make sure that you covered everything, okay? And I'm going to include another video with this one. Maybe it will also help you understand the difference between these two and which one actually makes more sense. Is it simple interest or compounding interest? Okay, I hope you have a good day, and I hope you guys stay safe. And thanks for watching.